And we're on the air. Okay. So what we're going to do, because this is all a review, fill out the missing values on your equivalency ratio table. Do that now, and I'll call on you. All right, we're back live again. So Aiden, what do you have for the two missing values? Don't automatically assume it's 2, 3, 4, 5. What I want you to do, because if you go back to lesson 13, you will see that when you do the equivalency ratio tables, there may be ratios missing in between. So the way I want you to do this, so stop and look, and you got to show this work. I need to see multiplicative structure. Just give me one arrow. And what do you get between the X bottles and Y total fluid? It's times what? Times 12. Okay. Once that's established, and I'm already telling you that the ratios are equivalent, even if you choose not to write it in times 12 for every set of ratios, you've got to say to yourself when you get to the two missing numbers, what number times 12 makes 48? Or 48 divided by 12, because when you go in the opposite direction, you're dividing. 48 divided by 4, 48 divided by 12, and that's how I come up with the 4. And then how do we come up with 5? 60 divided by 12, or if you do guess and check, 5 times 12 makes 60. Okay, that's kind of the way I want you to do it, because there's going to be times where this is in sequence 2, 3, 4, 5, but what if it was 2, 3, and I give you a 9 here? What would this be if this was a 9? Because it ain't 48 anymore. Luke, 108, you'd have to do 9 times 12. Okay. Value of the ratio. Get used to it. I want to do it like all the time. Hug. Not 3 to 4. No. But there's a number that still goes into 2 and a number that goes into 24. So reduce 2 to 24. Alexandra. 1 to 12. Okay? If that confuses you, remember that this is 2 to 24. Think of it like a fraction. Divisibility rules. Everything comes back down to divisibility rules. 2 goes into both. And that's how we get 1 to 12. All right, here we go. Equation for y. Y equals. Ryan Levine. Agreed. Let's see if it works. Always test it by, what's the S word? Okay, so let's see if it works. Joe D, give me a value for x on the chart. Make it simple. All right, 5. I'm supposed to get 60 if I substitute this in. 5 times 12 is what? It works. Equation is good. Luke. It is. Say, look, y equals, I give you the start. Y equals x times 12. They start you here. Yeah, they start you. All right, equation for x. X equals, they start it for you. Yeah, that's good. You're starting to see the pattern. Once you get that first equation, and that equation's been checked, and it's good to go, do you see what's happening? That you change the look, this changed from y to an x. This also changes. Multiplication changes to division, but the 12 always stays the same. So I know I was doing that with you this morning. You were starting to see that pattern, right? Aiden. There is. You want to see it? I'll give you a little sneak preview, but don't worry about it yet. He's asking, is there a symbol or another way that we use division rather than using this? And not to confuse you, nor do I want to explain it yet. Some of you may have seen it. Y divided by 12. You will start to see that exclusively when we get into Mod 4. Okay? You'll get used to it. Okay, so now it's substitution. Substitute what number, what value?
8.
For the value of x in my first equation. Okay, in my first equation, I'm going to rewrite it. Y equals x times 12. Oh, is it missing from yours? Let me see. Oh, it's there. It's just I divided it up into 3 lines for you. That's the change was made because I wanted. You're right. So
That's your first line.
that's my first line is the equation. I'll make the little headings for you. Then comes the substitution. So what gets substituted in for x? Michael? Correct. And then what's that last line say? Answer or evaluate? Evaluate. Evaluate means get the answer. So you just got to do 8 times 12 accurately. Good. 96. It's nice to see because over the last couple of days, you're progressing in the right direction. You're getting it. The more you practice it, the better it's going to be. Okay, so I'm gonna hit pause on the recording to give you time to read the word problem quietly to yourself, and then it'll start it up again. So as you've always been doing, read your word problem, underline what you think are the key parts of that math problem, and then we'll do it together. Nothing new here, right? Yonkers to Morgantown. I need the ratio, hours to miles. Amanda. How many have 8 to 400? Great. Now you got to do value. What number goes into both? And remember, if you can't do it all in one shot, break it down and do them. They're both divisible by 2, and if you have to break it down again, you will. You can break it down a whole lot. What do you want to use?
4.
You can use 4, but you'll see 4 will still get you halfway. You can break it down even more. Stace. Do you see why it's 1 to 50, everybody? 8 goes into both. Okay, 1 to 50. So based on the value, and this is kind of why we do value, you can figure out how many miles per hour that train is going. Because this, remember, this is 1 hour, or 50 miles, so it's going how many miles per hour? For what? For your value? When you get to 2 over 100, 2 still goes into both. 2 divided by 2 is 1. 100 divided by 2 is 50. Okay. Joe, how many miles per hour? Correct. Now I think, I don't know, you tell me. You know when you're in your car and the speedometer says 55 miles per hour? That's a ratio. It means in 1 hour you're going 55 miles. It's a ratio. Okay? All right, so now what I want you to do is from the value, which is 1 to 50, I want you to build every equivalent ratio, but leave ordered pair blank for right now because that's going to be the new part. Okay, I'm going to hit pause and then we'll come back to this. Okay, check it out. How did you do? Well, while we're at it, what's the multiplicative structure? Thorny. One more time. Times 50, absolutely. Sure, 1 times 50 is 50, and then it'll follow suit for all of your remaining equivalent ratios. Okay, so now you're just reading your data table, or you're reading your ratio table. Based on the ratio table that you just created, the one above, how many miles will the train travel after 3 hours? Brando? Correct. And since it's a word problem here, guys, put 150 miles. Give it a proper label. What about after 7 hours? Joe? 350 what? Great. Now here comes the tweener. 4.5. Nick Ellis.
4.5 is 225.
How did you do it?
Because for 4.5, it says 200, and if there was 1/2, it still doesn't equal 5, so half of 50 would be 25.
He's got it. So he's figuring, okay, well, 4.5's got to be halfway between 4 and 5. Therefore, I'm going to pick my equivalent ratio between halfway between 200 and 250. That's a good job. Oh, sorry, 225, right? Okay. Same idea now. How about 6.5? Amanda.
325.
Let me say 325. That works. So a lot of you guys figured that out, right? Now watch this, and I'm going to give you a time limit on this one, okay? What if I told you, and there's a reason why I'm asking this question, what if I ask you, how many miles has it traveled after 6 hours and 10 minutes? Giuseppe. How many miles has it traveled after 6 hours and 10 minutes? Luke, why do I have a feeling you know this?
No, what's that?
It's miles.
Oh, okay.
Mikey. See how you're trying to guess? The good part is that you realize it's somewhere between 250 and 300, right? See, hands down, hands down. There's a point why I asked this question, is that we're going to construct what's called a coordinate plane. It's like a line graph that will help us to see all of those miles and hours in between where you can look it up and get it right away. Okay? It's called a coordinate plane, and it's like a line graph. And what it does is helps us to see all of those little tweener ratios, because you got to understand that everything in between 5 and 6, 5 hours, 1 minute, 5 hours, 2 minutes, 5 hours, 3 minutes, has equivalent ratios in there. They're just going to be fractions and decimals, but they do exist. Hard for you to figure it out in your head, a little bit easier when you see it on the graph. So here's how we start. How many of you have done graphing in elementary school? Have you ever heard of an ordered pair before? An x-axis and a y-axis? Okay, great. So if you look back here, I've labeled everything for hours as my x. It's going to be a coordinate, as you'll see. Mikey, what's up? Yeah, take a shot, and this is it. What do you think? 305? Not 305. All of my y coordinates are going to represent miles. So watch how simple this is. We write an ordered pair starting with the x. So for 1 to 50, what's the x? Say it.
1.
Comma, what's the y?
50.
And then all you need to do is you put that coordinate or that set of coordinates in parentheses. That's it.
4, 200.
Okay? All right, do that. All right, then go to the next page, and this is kind of where this is like a little bit of a pain because you got to flip back and forth between looking at your coordinates and graphing it, but I'll help you out. Luke? Oh, I don't know. 10 minutes is 1/6 of the hour. So you got to do what's 1/6 of 50. 50 over 6. 6 goes into 50 8 times with 2 left over. You're looking at approximately, what did I tell you, 6 hours, 10 minutes? 600, 308, around 308 point something in there. You'd have to do it. You'll wind up with a decimal or a fraction. 842, 125th. 125th is, now you got me going. 308.004 miles. Okay. Raise your hand if you've done graphing in elementary school. Have you done line graphs? Have you done line graphs in science yet? You haven't done Bunsen burners yet either, right? You will when you do Bunsen burners. How many of you learned that there's an x-axis and a y-axis? Which one is the up and down axis, the x or the y? Because I asked. Which one's the x-axis? Which one's the y-axis? You missed the joke. I have to do that joke at some point this year. Did you get it? I go, which axis is the one that goes up and down? You go, why? I go, because I asked. Why? You get it? All right. 2 guys in a boat. Repeat, Pete and repeat. Pete fell out. Who's left?
Repeat.
Pete and repeat are on a boat. Pete fell out. Who's left?
Pete.
Pete and repeat are on a boat. I better stop on the head. This is all going on the blog. Anyway, Will, you're right. Y is what's called my vertical axis. Easiest way to remember, Y to the sky. Y to the sky, up, down. That makes this the X. Let me go full screen. X goes here. Back on track. Therefore, guys, I got to go back. This is not going to work for me either. I'm reaching down too low. It is what it is. I'm going to work at the bottom. I'm going to extend page. My X values, go back to your chart, is that miles? I know. Thank you, Mike. I'm good. Got it right up here. Go back to your ratio table. The X is representing what? Miles or hours? Say it, please. Hours. You're going to put a label at the bottom for hours, but look, I need you to leave room here because we're going to have to write numbers. So leave a little space. And so that's going to make my y-axis the other label, which is miles. Same thing, you're going to need to leave room right along this gutter right here for numbers. So give yourself some space. Okay, next thing is we've got to make our numbers. Far left corner is always going to be 0 for both hours and miles. And let me ask you this. How many total hours is in the ratio table? There's 8, right? Forgot. There is 8. So, if I start labeling here, I want to make sure I have enough room for 8 hours as I count across. I'm allowed to have a few extra boxes, but I don't want to run out of room. So I've got 1, and these are called hash marks or tick marks. To do this, 2, 3, 4, 5, 6, 7, 8, and I have a couple left over, right? But watch what I'm going to do. I'm going to put them in there anyway. As you'll see, they're going to come in handy. I'll extend the page so you can see. And then add your labels. I got to move hours down. label it all the way to 10. And let's just finish up and let's do our miles, because I know you guys have to go to lunch. Guys, hey, let's finish. What are we going to count by going up? Correct. And even though the table stops at 400, go all the way to the top, because you'll see we're going to need it eventually when I ask follow-up questions. And then once you have that done, we'll pick up where we left off during period 6. But that's a good start for today. Okay? Double check and make sure that everything is labeled before we continue. And that you've labeled miles for the y-axis and hours for the x. Because now we can start plotting our points. So what you do, and I'm only going to flip back and forth just once because you're going to kind of get the hang of what to do. But if you now take your first ordered pair, your x was 1 and your y is 50, and you're going to plot that on your coordinate plane. So you basically find 1 along the x, and then crawl up to your 50, and you put your first dot. Do that for the remaining ratios. 2 to 100, 3, and 150. And follow suit until all 8 ratios are plotted. The next part is very, very important. When you connect your dots, you got to use a straight edge. Which, in this case, normally I would give you rulers, but because of time, I'm going to hold off. Use the edge of your binder or something that's straight, because when you connect your dots, neatness counts. Not because I just want it to look neat, but there's a reason, is if it's a little bit off your line, you're not going to be able to read the in-between ratio values. And I can cheat because I'm the teacher. No, because I have the smartboard. And I can have the line tool that helps me here, but I want you to use a straight edge. And extend it. Watch what I'm going to do. Extend it past the last endpoint. It'll come in handy, as you will see. Is everybody ready? Okay, so now what we're going to do is I want you to use the coordinate plane to answer my questions. I'm actually going to do the questions on the next page, but if you don't want to keep flipping back and forth and you just want to look at the coordinate plane up here, whatever works best for you, honestly. If you need to flip back and forth, that's fine. But I'm actually going to start. Look, if you do go to the next page, which is 5, I'm going to start from where my finger is, because these 2 questions at the top we kind of already did. We did it last period. So starting with where it says use the coordinate plane on the previous page to answer the following questions. Ready? Question 1. Dinner service starts once the train is 250 miles away from Yonkers. What is the minimum time the team will have to wait before they can have their meal? Read it again. Dinner service starts once the train is 250 miles away from Yonkers. Giuseppe, just for the fun of it, can you say Yonkers for me?
Yonkers.
What? There it is. That's what I want. Yonkers. What is the... I have to have my small joys. What is the minimum time the team will have to wait before they can have their meal? Is it math related to what I just asked? Because if not, I want to hold off. Oh, I get it. Aiden, you going to answer the question? All right, for, what do you got, bud? How many think 5 hours? All right, well, let's get back in gear here, okay? after 250 miles away. So let me just show you how to do it. I find on from where it says my miles, 250, which is going to be right here, right? And I trace across until I meet my horizontal line. And then where it meets, you trace down. And Aiden is right. 5 hours, 250 miles. Which, again, you can do this from the ratio table. I get it. But it becomes easier to use this coordinate plane when you have to start kind of getting an idea of the in-between hours.
Wait, so what do you put down? 250.
After 250 miles, it's 5 hours. I don't know. Maybe you mislabeled somewhere, bud. There could be a labeling issue somewhere. You see it? We're good? Okay. Ready? Next question. If the train broke down after traveling 350 miles, how many hours would it have already traveled? 350 miles. Well, do you see that it's 7? Do you agree? Okay. We're on page 5 if you want to fill the answers as we go. On page 5. All right, question 3. About how many miles will the train have traveled after 5.5 hours? 5.5. Right, Levi? How much? How many think 275? Does anybody not know how we get that? I'll show it to you. 5.5 hours, right, Aiden? So you find 5.5 hours. I'm going to use the line tool again. Here's my 5.5, halfway between 5 and 6, right? Trace it up until it meets the line. Then trace across. And even though this is not perfectly precise, that line's supposed to be halfway between 250 and 300, which is 275. Which is halfway, if you think about it, halfway between 50 and 100 is 75. So between 250 and 300, 275. Okay, number 4, we're starting to get a little harder. How many miles will the train have traveled after 9 hours and 30 minutes? Aha, 9 hours and 30 minutes is past the coordinate plane, isn't it? That's why we extend the line. 9 hours, 30 minutes. Joe D. Maybe you agree with Joe D, 475. Great. I'll trace it without actually drawing the line. But here's 9.5 right here. I trace up to where it meets the line. I trace across. And halfway between 450 and 500 is 475. You want something harder?
Yes.
All right, you ready? Here we go. Now you got to kind of visualize where this line is going. Or if you're really smart, you're going to start to realize that you can formulate an equation to start figuring this stuff out. But we'll get to that. How many miles at 11 hours? Seppi, what do you think? How did you do it? You are right. 550 is correct. That's it. It's 11 times 50. See, once you have that multiplicative structure, he knows, okay, it's my hours, whatever hours I give him, times 50. Think about what you just did. Watch. Hours is X or Y. Hours are X or X or Y. Watch what we just did. X times. Oh, sorry. x, which was 11, times 50 equals my y. I told him that x is 11. Substitute it into the equation. You have your answer. Starting to connect or no?
Yeah.
Sort of. And what's great about this is I can give you now, you don't even need this. What if I told you 100 hours? Do you really want to extend this all the way to like infinity? No. Plug it into the equation. 100 hours. Yeah. 5,000 miles. That's the beauty of using equations if you're comfortable with it. Steppy, I owe you a candy. Ready? Going to get harder now. Ready? How many miles at 3 hours and 45 minutes? It's a hard one. Oh, that's a hard one. Good luck with that. How many miles has the train traveled at 3 hours and 45 minutes?
Where is that?
Well, I can tell you where it is here. 3 hours and 45 minutes. If you realize 45 minutes is 3/4 of an hour, that's about here. This is tricky. I don't expect you to get this. But maybe I'm going to put it out there to see if you can. I'm asking questions that are not on the page now, but you're still using the same coordinate plane. I'm going to take 3 guesses and then that's going to be it, okay? Because I do want to move on to the other stuff. These are like really advanced questions. So 3 hours and 45 minutes would be how many miles? Pick somebody. Here he comes. Not 4:30. Here's kind of, you got to kind of get into the ballpark. Here's 3 hours and 45 minutes. If I trace up, I know that my answer has to be between 150 and 200. Exactly how much is the hard part. Pick somebody. Close, but not 185. Last crack. Luke? I'm going to my horses. Got to go to my horses. Mikey. Last horse, Tyler. 187.5. You were close. 187. It is. What's halfway between 250 and 300? I'm sorry. What's halfway between 150 and 200? Okay, halfway between 175 and 200. You got to add 12.5 to 175 to do it. Because halfway between 175 to 200 is 25. Halfway is 12.5. You were on the right track. You had it. You took your 12.5 and you added it to 160 or 150 instead of adding it to 175. Tough question. Okay, so I want to stop the blog for now because you get the gist of it. We're just going to practice with another coordinate plane, another